Within our solar system, a single planet was selected as a remote laboratory where the search for life would begin. This is the world-famous Lowell Observatory on Mars Hill in Flagstaff, Arizona. Percival Lowell founded this observatory in the course of a lifelong study of the red planet.
Percival Lowell founded his observatory in 1894 at Mars Hill in Flagstaff expressly for a study of Mars, which interested him. He did this visually, first using a borrowed 18-inch telescope set up in Flagstaff, while he had ordered a larger refractor from the outstanding telescope maker in the country, Alvan Clark. And during the course of the first year, observed Mars in opposition with the 18-inch telescope by making drawings of what he saw.
Lowell's interest in Mars was first sparked after studying the work of an Italian astronomer, Giovanni Schiaparelli. In 1877, Schiaparelli prepared a series of maps of Mars, adding a commentary to help describe what he saw. The most curious features were a series of vague dark lines connecting darker areas, areas then thought by many astronomers to be oceans or seas. To describe these lines, Schiaparelli used the term canali, which in Italian means channel or groove. But canali became canal in English, and canals, if they existed, also implied the existence of intelligent beings. This, at least, was the theory advocated by world traveler, author, and amateur astronomer Percival Lowell. In a series of 3 books, Lowell explained his personal and highly imaginative theories about Mars and its canals. Lowell's thesis was that Mars was a dying planet. He believed it had very little water, except for what existed in the ice at the polar caps. Lowell thought the canals were the work of intelligent beings who knew that the only way to distribute water to the warmer equatorial regions of the planet was to construct a series of canals emanating from the melting polar ice caps. Eventually, Lowell identified over 500 canals. While Lowell was not entirely alone in his theories about intelligent life on Mars, he was still in the minority among the scientific community. Many astronomers countered that they could see nothing similar to what Lowell claimed, even with the best viewing conditions. Although he never thoroughly convinced his fellow astronomers, Lowell's effect upon the public imagination was profound.
Everybody, listen carefully. The Martians are coming this way. We must evacuate the city. Take food and water and extra clothing with you. All major highways have been marked to lead you to shelter and welfare centers in the hills.
Enemies of Queen Azula. Who are you?
We're from another planet, the Earth.
Why did you come to Mars?
To stop the destruction of our own planet by Queen Azura and her ally, Emperor Ming.
Destroy the Earth?
Lowell's vision of an inhabited Mars was translated directly into science fiction. Everything from Edgar Rice Burroughs' space westerns with John Carter to Orson Welles' 1938 broadcast of the War of the Worlds, which panicked the East Coast, and of course, numerous motion picture versions of the threat we face with invaders from Mars. But speculation about canals on Mars and other alleged signs of life there isn't equal to proof of the existence of life on that planet. For proof, we have to gather the very best factual information we can about Mars. And we've learned a great deal more about the angry red planet since the time of Percival Lowell.
In the scheme of our solar system, Mars is the fourth planet from the Sun. Its orbit around the Sun is more eccentric than that of Earth's. At its farthest point from the Sun, or aphelion, its distance is over 158 million miles, or 248 million kilometers. At its closest point to the Sun, a place in the orbit which astronomers call perihelion, its distance is 129 million miles, or 208 million kilometers. When the Earth moves between the Sun and Mars, Mars is said to be at opposition. That is, it's in the opposite direction from the Sun. Because of its eccentric orbit, Mars comes closer to the Earth during some oppositions than others. At the closest possible opposition, they are approximately 35 million miles, or 56 million kilometers apart. Around the period of opposition, which occurs every 2 years and 2 months, astronomers get their best glimpse of Mars. These observations are noteworthy. Two polar caps grace Mars, top and bottom. These polar caps expand and contract depending upon the season. The surface of Mars also undergoes seasonal color changes. These seasonal changes are analogous to Earth's, although their duration is much longer. The Martian year, the time it takes Mars to orbit the Sun, lasts 687 Earth days. Although its year, or sidereal period, is different than ours, Mars has other characteristics similar to Earth's. The tilt of its axis, an important factor in seasonal shifts, is approximately 24 degrees, only slightly greater than that of Earth's. Also, the Martian day, the time it takes to make one complete rotation, is 24 hours and 37 minutes. This period is determined by watching a particular Martian surface feature. Observing how long it takes to be carried around the planet determines the rotation period. When comparing the size of Mars to Earth, however, there is a great difference. The diameter of Mars is slightly over half that of Earth's. This means that the surface area of Mars is about 1/4 of the Earth's surface area. The mass of Mars has been determined as approximately 1/9 that of Earth's. Its surface gravity is 38%, or a little more than 1/3 of our own. Also, while our planet has one moon, Mars has two. The Martian satellites were discovered in 1877 by an American astronomer, Asaph Hall. Deimos, the outer satellite, is about 8 miles or 13 kilometers in diameter. Phobos is larger, about 15 miles or 24 kilometers in diameter, both appearing as tiny spots when seen from Earth.
We've been watching Mars in the nighttime sky for thousands of years. And for the past few centuries, we've been able to gather information about it through our telescopes, although it's required patience. But now, in an era of interplanetary spacecraft, we're able to see Mars face to face. And this began with the Mariners.
We have module VEB and the alpha string, VEA and the beta string, and the command system is initialized.
This is the control center for unmanned space probes at the Jet Propulsion Laboratory in Pasadena, California. From this room, scientists can monitor the journey of spacecraft millions of miles away.
It's food for the spirit of man, and it's food for the spirit of our children and our grandchildren. This is our contribution to the long history of mankind. The idea of discovering a wholly new place like Mars and enlarging our consciousness and enlarging the view of all of us and of our descendants about not just the world, but the reality we live in, is as important as music or art or certain kinds of...
Since 1964, Mars has been visited by 8 American spacecraft. Dr. Bruce Murray has been closely involved in spacecraft studies of Mars from the start.
Mariner 9 looked at a different part of the planet than Mariner 6 and 7 and Mariner 4 had. And to my astonishment in particular, and to that of many people, there were huge volcanoes. The largest volcano in the solar system, which is called either Olympus Mons or Nix Olympica, depending on when you learn the name. So Mariner 9 revealed what was almost a different planet than had been revealed before.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, ignition.
On May 30th, 1971, Mariner 9 began its 6-month journey to Mars. But a few months later, ground observers saw that a dust storm in the southern hemisphere of Mars was growing and spreading across the surface. And soon, all visible markings disappeared under the blanket of dust.
As the dust storm continued month after month, a lot of us began to get very anxious about whether the cameras would be able to see anything.
Ready to copy? Roger, predicted downlink 159.3, actual 159.3.
When the dust finally cleared after nearly 2 agonizing months, what we saw was a real shock. The photos showed a gigantic volcano with a large crater at its top. At first, I really couldn't believe it. A volcano would mean that Mars was alive and active inside, and not a cold, dead planet.
A close-up photo of Nix Olympica revealed what looked like lava flows and tunnels. This one feature, an immense circular volcanic mountain, prompted scientists to reconsider everything which had been theorized about Mars. The size of Nix Olympica alone is staggering. The state of California is almost 300 miles across. But Nix Olympica is even wider. By far, it's the largest known volcano in the solar system. Additional close-up photos were taken in orbit after orbit, then pieced together into a detailed mosaic map, revealing that the other 3 spots were also gigantic volcanoes, each over 200 miles across. Another major discovery was an immense canyon of extraordinary dimensions running along the equator of Mars. As Mariner 9 passed over the surface, instruments measured the depth of the canyon. Incredibly, it's over 3.5 miles deep at many points. On Earth, it would stretch from Boston to San Francisco. Arizona's Grand Canyon would be an insignificant crack by comparison, and this on a planet half the size of the Earth.
The fact that Mars has volcanoes on one side and mainly craters on the other means liquid rock has poured out on that one side and destroyed the older landscapes there, but that this process hasn't yet spread around the whole planet. We now believe that Mars is just beginning to heat up inside.
Didn't you know the heaviest crater place on the planet is where we haven't seen Mariner 6?
It may look something like the Earth did billions of years ago.
Let's go look at the next one.
If you actually plotted on a stereographic net the location of the center of rays of curvature, there'd be a series of points, and there'd probably be a family of points lying off of here someplace.
Around 340.
So the question that arises is there pole wandering, and is this in fact the hallmark of a previous pole positions, actually? And is that the explanation of the offset? And I'm going to assert that I think it is.
Whatever it did in the past, it is doing now, or whatever it is doing now, it has done in the past. What I see now is that all these things that enable us to see these streaks and things, whatever it is, it's not on the pole. Show me the thing that's centered on the present.
Although the various missions to Mars have thoroughly disproven Lowell's theories about a system of canals on the red planet, they revealed something just as mystifying: hundreds of ancient meandering stream beds. But there's no indication of liquid water on the planet.
Let me finish up the set of ideas, and we'll come back to picking them apart, because there are lots of places to pick. Probably the biggest argument focused on the question of water. Close-up pictures of the edges of the canyon show erosion which some scientists feel looks very much like water erosion on Earth. Water essential for every form of life as we know it. And if water formed this feature, it could be an indication that life too might have formed.
It's really frustrating. We build better and better instruments, and we learn more and more about the planet. We even send space probes into orbit about Mars to send back pictures. But the question of life still remains. And if we can't detect life on Mars from Earth-based observations, or from probes in orbit about the planet, then we have to land on the planet itself. And that was Viking's mission.
Late 1975, Viking 1 and Viking 2 set out to achieve the first soft landing on the Martian surface. Their primary objective is to search for evidence of life on the Martian terrain in a series of 3 experiments.
Indicates that we have initiated the pre-entry pitch over where we'll hold the 120-degree angle of attack.
Telecom lead, how's the SNR and high rate?
SNR is holding very well. It's reading 8
In the atmosphere now.
Quarterly stroke, delayed stream. We are converged 2.7 Gs. Good rate damping. 10,900 feet per second. 8.4 Gs. Good low latitude hold. Firm water power. 4,800 feet, 177 feet per second. Confirm roll maneuver. Center sheet separation. 366 feet, 73 feet per second. ACS is close to vertical. Nav is green for touchdown. ACS is green, 1.5 degrees per second max, 0.2 Gs. 8 feet per second. Touchdown, we have touchdown. Exit zone. Stabilis zone. Number 1 zone. We're looking good.
And there's the first piece of information coming in. Oh, more, a few rocks.
That's beautiful. That is the footprint, and that's a reflection from the surface. You can see that there's been relatively little disturbance of the surface materials. Meteorology, well, sensational. A very bright sky, but you can see the horizon.
Dr. Bruce Murray recalls the initial results.
It looks like it's sloping down to the right, isn't it? Oh, isn't that? That's
The first
fantastic.
pictures from Viking were amazing.
That's fantastic.
The onboard cameras revealed a gently rolling landscape strewn with boulders. The cameras revealed a varied landscape surrounding Viking 1, even including a boulder about 2 meters high. The color pictures were incredible. They showed a vivid orange-red surface suggestive of a high degree of soil oxidation. The thin Martian atmosphere was analyzed. Nitrogen was finally discovered on Mars and found to be much less abundant than on Earth. Argon, on the other hand, is more abundant. These differences from the Earth in atmospheric composition suggest that Mars did have a different, probably denser atmosphere billions of years ago.
Viking also provided new information and the closest photographs to date of the two Martian satellites, Phobos and Deimos.
Phobos and Deimos appear to be comprised of a carbonaceous chondritic type material, which might be 20 to 30% water. Other than that, there's no evidence of water or atmosphere on the surfaces. The surface gravity of these small bodies is less than like 1,000th that of the moon. A couple analogies would be one could easily orbit a baseball from these things by just throwing it fairly fast. If you include the gravitational effects of both Phobos and Mars, it only takes about 3 meters per second on Phobos to escape, and one can, on Earth anyway, can run that fast. So you can almost imagine running and hopping off the thing.
Cameras from the main part of Viking 1, still in orbit, revealed many more strange flood-like features similar to those found by Mariner 9. These winding channels and teardrop islands probably were formed billions of years ago. There is little alternative but to conclude that catastrophic floods did indeed once flow across the surface of Mars. Viking 1 gave us the first opportunity to look for life on another planet. A sample of the Martian soil would be scooped up by a mechanical arm and then placed into the laboratory. All of the complicated digging motions had to be first practiced on a duplicate lander on Earth. Then Viking 1 on Mars was commanded to repeat them. When the laboratory results came in, chemical changes were detected. More soil samples were taken. But the laboratory did not find any organic material at all. This made the scientists look back at the chemical changes more critically. Without the presence of organic material, it seemed unlikely that the chemical changes observed were really caused by life. An identical lander on Viking 2 would have to be successfully landed to find out if the soil was the same in other parts of Mars. Perhaps the ultraviolet radiation was making the Martian soil unsuitable for life. So, to see if chemical reactions would be different in an area protected from the sunlight, the mechanical arm was programmed to push a rock over and to scoop the soil from beneath it. But these samples from beneath the rock, as well as those exposed to the ultraviolet radiation, gave the same results as Viking 1. These results probably never will be fully understood until a sample of the soil of Mars can be tested thoroughly on Earth.
Dr. Harold Mazursky at the United States Geological Survey in Flagstaff, Arizona, was the head of the committee which selected the Viking landing sites and was involved in the extensive analysis of the Viking results.
Well, people are still debating as actively now about the biology results as they did when they were first coming in. There were 3 independent instruments, and they were supposed to test for growing things. That is, the ultimate test is whether something will reproduce itself. And they tried to do a very wet experiment, a sort of semi-wet, and a dry one to cover all the possibilities. And they got sort of 2.5 positives. That is, they set the criteria, and the instruments met them, so that at least one of the experimenters wanted very badly to announce that they had found life. Unfortunately, they had the gas chromatograph mass spectrometer, and that was supposed to analyze for complex organic compounds. So first they were supposed to see metabolic activity, and they thought they did, and then confirm it by actually getting complex organic molecules, and there were none. In the limits of detection, they found no complex organic materials. So they've been driven to an interpretation that what they're seeing is some kind of very complex chemistry of the soil, and it imitates life incredibly well. See, they tried an experiment and got a positive reaction. Then they sterilized the sample and tried it again and got no reaction. And that was supposed to be the ultimate test. And apparently whatever causes the chemical reaction acts as though it's living material, except they don't see any trace of it in the chemistry. So it's a great puzzle.
Mars has a fascinating and unique geological history. Is it possible that this barren, inhospitable planet once had an abundance of water and a rich enough atmosphere to support life? Sometime in the future, an emissary from Earth will walk on its bright red soil. And with the successes of the Mariner and Viking missions, scientists have gained a wealth of invaluable information to prepare for that day. But even now, we've learned enough to lay a few thousand years of imaginative fantasies about this angry red planet to rest.
On July 20th, 1976, Viking 1 set down on the sands of Mars, commenced a 3-month intended mission. And in fact, Viking exceeded our wildest expectations. It outlasted its twin, Viking 2. It outlasted the 2 Viking orbiters that stayed in orbit around Mars. It lasted for over 6 years, and it wasn't until mid-November of 1982 that we received our last signals from the Viking spacecraft on Mars.